there's a prompt, a story, or something they want us to consider while we're working through the material. It says, study links dark chocolate to heart health, video games shown to boost IQ, and college grads live longer, a new study finds. So they got everything in here in quotes, and what they proceed to tell you is you've probably seen or heard headlines similar to these in magazines, on TV, and online. Each one of these headlines is the result of a correlational study. So they say here, in a correlational study, researchers, they compare two variables to see how they are associated. In the chapter, we're going to be comparing a lot of variables, and we're going to see how they're associated. So, in the world, they do these headlines. They do this through the use of surveys, or even by researching documents, such as medical records. What methods do you think researchers could have used to produce the results mentioned in the headlines above? So when you start looking at methods, some methods are more accurate, they're more authentic, and others, they're invalid, they're fake, they're bogus. But sometimes for headlines, they do whatever they can to get the data to reflect whatever they want, Video games to boost IQ, new study links dark chocolate to heart health. Kind of reminds me of the cigarette ads in the 50s and prior, and the sugar ads. They would say sugar would help you lose weight. You could Google those. In either case, let's take a look at problem 1. Right here they say, recall that data comparing two variables can show a positive association, a negative association, or no association. Okay, so right here, let's go ahead. A positive association. When it's a positive association, on a graph you got stuff going up. That's a positive association. If it's a negative, then it's going down. And when it's going up, it's going from left to right, because we read left to right, like a book. Similarly, a negative association is when it's going down from left to right, just like how we read a book. So that's negative. And then there's no association. For no association, it may be that the data, it just doesn't fit a line. It could be data that's just kind of plotted all over the place. Doesn't really fit any particular line. And maybe over here, the data, it's all around this particular line. And the data here, it's all around this line, so it's a negative association. So here they say, describe the type of association between independent and dependent variables shown in each scatter plot. Then, draw a line of best fit for each if possible. Okay, so what we're comparing here, let's see, on the y-axis we got miles per gallon, and on the x-axis we got the weight of a vehicle. Let me move that up a little bit. So if we try to do a line of best fit, I got this card here from the mail trying to get me something. Maybe about right there. I don't know, that looks pretty good. We'll just put a line right there. You notice the data, it's all around the line. And the line is, from left to right, it's going down. So we could say this has a negative association. So we could write that in our statement underneath. We want to write a full sentence, so we move it up a little bit. So we could say there is a negative association. We've got a negative association, but what's it between? On the x-axis, we got the weight of a vehicle. On the y-axis, we got miles per gallon. So we could say there's a negative association between, move that over, we could say weight of a vehicle, weight of a vehicle, and miles per gallon, right there, miles per gallon. And then we could also describe it. We could say, you know, right here would be our origin, 0, 0. And as the weight, as we're getting heavier, we could say the miles per gallon, the efficiency of the vehicle, it goes down. So, you know, if you got some kind of light Honda, your mileage is way up here, you know, like maybe a Honda Civic. It's got higher gas mileage. If you're driving a classic car, maybe one of those big Hummer vehicles, you're over here. You know, maybe something with a big turbocharger or a supercharger, you're over here. The vehicle's probably heavy, and it's not getting that much miles per gallon. So, probably got a lot of horsepower, but not a lot of miles per gallon, not as efficient. So we could say, as the weight increases, and what we're talking about here, we talked about weight, miles per gallon. As weight increases, miles per gallon does what? It goes down, it decreases. Okay, so that takes care of that one. Let's take a look at some of these other ones here. Alright, we've got B and C here. And if we look at B, what we're comparing there is height and IQ score. And if you notice, we could take this card, I guess maybe something might fit there, maybe here, maybe there. I mean, those dots, it kind of seems like, it doesn't really fit in any direction. And if you kind of think about it, your height and your IQ score, those two don't normally correlate. You know, people that are tall or short usually doesn't determine their IQ score. So we could say there's no association between IQ score and height. Just from thinking about it, you know, common sense wise, everyday real world experience, and also these dots here, they reflect that as well. So let's turn that into a statement. Let's write something to reflect that. There is no association between, okay, what are we talking about here? Well, we're talking about IQ score and height. So we could write IQ score and height. And how do we know this with the graph at least? Well, our line of best fit, it didn't make sense. So we could say no line of best fit would make sense. Yeah, we tried putting it on there and it just wouldn't go. Okay, let's take a look at the next one. Right there, graph C. That one you can see the data. It's pretty much in this group, and it's got an upward trend. So we could put a line through that fairly easily. Let's go ahead and do that. I'm thinking, let me turn this card around. Maybe here. Maybe about, yeah, right there. I like that spot right there. We'll go right here. Okay. So we got our line of best fit. So let's make two statements. We want to talk about the association. Is it positive or negative? Well, we know it's going up, so we could say it's positive. So we could say there is a positive association between what? Between time spent studying and grades on an algebra test. Between time spent studying and grades on an algebra test. Now we also want to state, how do we know this? Well, we know this because at the beginning of the graph, less time spent studying results in a lower score, a lower grade. And then as we go this way, it's more time spent studying, and the grade is higher on the algebra test. So we could say as time spent studying increases, grades on the algebra test increase. So we could say this. As time spent studying increases, grades on an algebra test the grades on the algebra test do what? They increase. Alright, so we're done with that page there. Let's go to the next one. Okay. Let's take a look at what's going on here. I'm going to move it down just a bit. A measure of how well a linear regression line fits a set of data is called a correlation. Okay, so something we're talking about here, we're talking about a linear regression line. And we're talking about data and how well the linear regression line fits the data. That's called correlation. Now we've got something else. The correlation coefficient, that's a value, and that value is between -1 and 1. So let's just go ahead and circle that real quick. Between -1 and 1. The correlation coefficient is a value between -1 and 1. That's important. You want to remember that. Which indicates how close the data are forming to a straight line. So the closer the correlation coefficient is to a positive one or a negative one, the stronger the linear relationship is between the two variables. The variable r, so we're looking at the variable r right there. Let me underline it too, because we want to come back to that. Is used to represent the correlation coefficient. So r is our correlation coefficient. It says over here, the tutor here on the side says, I remember that the correlation coefficient either falls between -1 and 0 if the data shows a negative association, or between 0 and 1 if the data shows a positive association. Well, let me help you visualize that really quick. So what he's talking about, if we have a negative correlation on a graph, let's say we got data. And the data, you know, it kind of fits the negative correlation, so I'll put negative. Then, ideally, you want all the data to be -1 And it could be a value between 0 and -1. But you don't want it to be 0, because what happens is at 0, you get something like this. And that's like a horizontal slope. It's not a positive or negative correlation. You end up having no correlation. And then right here, that would be your positive correlation. So that'd be a positive one. Basically, the graph, if it's close to +1, it's got a stronger correlation. If the data gets close to 0, like if it's a decimal, then it's got a weak correlation. And if the data goes negative into a decimal, if it's close to 0, it's a weak correlation, but the closer it gets to -1, it's got a strong correlation. So weak versus strong correlation, that's what we're looking at. So let's go ahead and start working through some of this. Determine whether the points in each scatter plot have a positive correlation, a negative correlation, or no correlation. So right here, positive correlation, negative correlation, or no correlation. 4 possible R values are given. Circle the R value you think is most appropriate. Explain your reasoning for each. So we got to explain the reasoning for that. Let me go ahead and move that up a bit. Okay, so they give us, for values there, they give us 0.9, they give us -0.9, they give us 0.09, and -0.09. Okay, so we can see right off the bat, if we were to try and draw a line through these pieces of data, we could get a line going, maybe something like this. Just going like that. And we've got a negative correlation. So we got a negative correlation. We see it's fairly obvious. It's not something we gotta guess on. So it's not going to be a positive value. So right here, this one here, this one's positive. So this is gone. We know this one's out. This one right here is positive, so this one's out. We're not using those. So it's got to be this one or this one. So here's how it works. It's got to be close to -1. -0.9. If I were to round this, this would go up to -1, because you got a -9 here. If you rounded this part up, it would round up to -1. If I rounded this one here, you would end up with -0.1. And -0.1, that's closer to 0, whereas this one here is closer to -1. So we don't want the one that's close to 0, because this has a strong negative correlation. So we want this one right here. Now we got to explain our reasoning. Just figuring it out isn't enough. We have to demonstrate through a written sentence. So we could say the data here that we looked at, it shows a negative correlation. So we could say the given data, all this data was given to us, the given data shows a negative correlation. And because it has a negative correlation, we could say that R value must be negative. So we could say because of this, the R value must be negative. And we could say also, the data, they're close to forming a straight line. Also, the data are close to forming a straight line. So what that all comes down to is our R value is negative 0.9. That would be the most accurate. Okay, let's go ahead and move along here. Just want to point out what she's saying here. The closer the R value gets to 0, the less of a linear relationship there is in the data. Just to reiterate. Good little points there. Okay, so they give us more data there. If we are considerate, and let's take a look at it. I feel pretty comfortable about imagining a line going through it. I would say the line's going in this direction, or the data's going in this direction, so a line would have to go through there. So I'd do something like this. Put a little arrow on it. And I'd say this has a positive value, or a positive correlation. So, right off the bat, if this is positive, we can cross out the negative ones. We know this one's out, that's done. This one's out, that's done. So we're left with just 2. And is the data kind of close? Yeah, it's close in there. So we could, if we were to try to round these here, if we were to round this 7 would make that 0 become a 1. So we'd be with 0.1. And this one here, if we were to round this 7 would make that 0 a 1. So that would become 1. So what ends up happening is we've got a positive relationship. It can't be negative. We want it to be positive. There's a 1 here. We notice these dots, the data, they're real close to that line. So this would indicate a weak relationship. This one here would be weak because it's close to 0. And this here would be strong because it's closer to 1. So we're going to go with this one right here. And then let's go ahead and write out what we see here. Well, we see these data, these given data. So these given data coordinates show a positive correlation. They show a positive correlation. You could say because of this, the R value must be positive. And we did find our R value was positive. We also noticed the data they were fairly close to forming a straight line. So we found that our R value was 0.7. That was the most accurate. Mitsunak, can you get that? So also the data are fairly close. To forming a straight line. So R equals 0.7 would be the most accurate. Okay, so that takes care of that, and that's the rationale for it. Really important there. Okay, now before we continue, we're just gonna take a look at only this problem on this page. And I got my little note there for you. So we got this problem we're gonna take a look at. Right here, we got R equals 1, R equals 0.5, and R equals 0.01. And if we take a look at all this data here, what do you notice about it? Does it look positive? Does it look negative? Or does it look just kind of scattered? So right here, 1, a positive 1, that would be a strong correlation. R equals 0.5, that would be kind of like a mild. That would be like kind of a mild correlation. Oh, I forgot an R there. And then right here, this one, that's close to 0 if we were to round this. So this one here would be a weak. Now this would be a weak correlation. So those are our 3 options. And if we look here, if I try to draw a line in this thing, you know, if I was here, here, maybe like that, it just doesn't seem to really have a line that really stands out with those dots, that really matches up with them. So I'm going to say this is a weak correlation. So now we've got to explain that. We've got to explain this weak correlation. So we could say these given data points show no correlation. Let's see, we could follow it up with maybe, since there's not a linear relationship in the data, the R value would be close to 0. So since there is not a linear relationship in the data, move that over just a hair, the R value would be close to 0. So we could say so our R value, R equals 0.01, would be the most accurate. Okay, so now that we've gotten that far, what I want you to do is I want you to go ahead and stop with everything that you've done. I want you to think about everything you've done, and then I want you to take a look at skills practice. I want you to do the skills practice problems 1 through 6 on pages 493 through 495. After you do those, because those problems they directly reflect what we just did, then come back and continue to watch the videos. Because then what we'll do is, I'll show you how to do a problem or two, and then I'll assign you some problems. And it should make it a lot easier.